We've already taken a vector and turned it into its x and y components, or its horizontal and vertical components. Now we're going to do exactly the opposite. We're going to start with the x and y components, and we're going to see how really easy it is to get that resultant vector. And remember, a vector has both direction and magnitude. So when asked to find a vector, whether it be a velocity or an acceleration, you're going to want to find both the direction, also known as the angle, and the magnitude, or the size of that vector. So let's see how easy it is to do. We already did a force summation. Let's pretend, and we ended up with our components. However, the question is asking us for the complete vector force. Well, if we have the components, we definitely can do this, and I'm going to show you how easy it is. The first thing we're going to do, of course, is make a sketch. I'm going to say this is my x component of force, which is 2 newtons. I'm putting it to the left because it's negative. And my y component of force is 3 newtons, and that's going upward. Now notice here, I didn't put -2. That's because the vector is going to the left. I indicated the direction by the vector itself. This, of course, is a right angle between the x and y components. Now that resultant force is going to go from the tail of my first vector to the head of my last vector, and this is the force that I'm looking for. Let's find the magnitude first. We're going to reach into our old bag of tricks, and I'm going to say, hey, that's a right triangle. I can do so much with a right triangle. I'm going to start by finding what this length of the hypotenuse is, and I know this is the hypotenuse because it's across from my 90-degree angle, and it is the longest side. So the Pythagorean theorem basically says if I take the square of the x component and the square of my y component, that is going to equal the square of my resulting force. So I'm going to quickly do this math. Now we have the magnitude of that force. Now I'm going to round that to sig figs. In this case, we have barely any sig figs at all. We just have one. So the magnitude of my force is 4 newtons, but I still need the angle of the force. Well, it's always best to find the angle from the tail of that force. So I'm going to find the angle relative to horizontal. If this is the angle in question, now I'm going to define the sides of my triangle in terms of opposite, adjacent, I like to call it attached, and hypotenuse. I already know this is the hypotenuse. If this is the angle I'm looking for, the side that's attached to the angle is this side right here. So this is going to be called the attached side or adjacent side to make all those trig teachers happy. Across from that angle, the one that's not attached and it's not the hypotenuse, is the other side or the opposite side. Well, because these are the two values I was given, if I take a look at SOHCAHTOA, like my Mohawk family would say, I would know that if it's O and A that I have, I can use the TOA feature, and that represents tangent theta equals the opposite over the adjacent. So tangent angle, and my theta would be 56 degrees. It's as easy as that. Every single time. Don't panic. It's easy. So now, to give my force, remember, same method with any vector you're trying to find, I'm going to write it in terms of the magnitude and the direction. Now, because this here is not 56 degrees from the positive x side, it is not a vector this way. This would be 56 degrees from the positive x direction. We can either we can just specify it with words. 56 degrees from negative x axis and call it a day. Make it a great one.